Well, welcome again. This is Dr. Sam Hijazi. We're going to be talking about F-test. F-test is a really powerful test, and it's going to really do the, as a statistical analysis, is going to look whether the null hypothesis that the variance of two population are equal or not. So the null hypothesis is the initial hypothesis if the two variances of two population are equal or not. As you notice here, uh, um, actually I copied and cut this because it's going to take me forever to use the symbols to write it. That's actually this one here is the standard deviation symbol for the population, and this is the null hypothesis. The first uh, uh, variance for the first population is equal to the second one. Remember, variance is equal to standard deviation, right? So the second power or square of the standard deviation. The alternative hypothesis is those two variances are not equal. So that's what we're going to be looking for in this F-test. F-test is also a very powerful test. We're going to be able to use that in the future in a lot of business and econometrics analysis. So I'm going to go ahead and do the F-test for two samples for variance. We only have two samples. These two samples do not have to be equal in observation. And we're going to go ahead and see if the two variances for the two population are equal or they're not equal. And whether if they are equal, we're going to accept the null hypothesis. If not, we're going to reject the null hypothesis. So I'm going to go ahead, as we could see early, how easy it was to do that through the data analysis under the data ribbon, under data analysis that I added through the adds in under the option. And I'm going to look for the F-test with two samples for variance. And I'm going to go ahead and click on it. OK. Now it's going to ask me for the range for the first variable. So we're going to go ahead and include the female. The female, which means the number of the hours they studies every week. This six observation for female and 5 observation for male. That's variable number 2, which is the male, including the label, because I'm going to immediately go ahead and check on the label. And of course, we're going to go ahead and click the output. But please, before you do anything else, check this text box, because if you forgot, the address is going to go here directly. So I'm going to go ahead and make sure that it's checked in the right text box, and I'm going to click on here so I could actually display the result of the analysis directly under it. And I'm going to go ahead and say, okay, go ahead for it. Let's go ahead and see what we got. So now it's very easy to do. And notice here all the statistical description. We have the mean 33 for the number of the hours the female study every week, while the males 24.8. Obviously, they're not doing as many hours as the females. The variance way too large with 160 versus 21.7. So remember the null hypothesis, we're saying that the variance are equal, and we will see whether we're going to actually reject it or accept it. The observation 6 females and 5 males. So now we're going to look again at the two different values for F and the critical values. Of course, I'm going to go ahead and click on this in order to expand it, right? I know the data here doesn't look good, but for now, we need to go ahead and focus on this side. And now, if you look at this one here, that's the F value, okay? It's going to be in yellow here. Could go ahead and change that to, let's say, green, okay? So if first of all, we need to make sure that the variance of the variable 1 or the first variable is higher than the variable of variance 2. If this is the case, which is 160 is larger than or greater than 21.7. If not, we need to swap the data. So Excel calculate the correct value as a result of swapping the data. So again, this is the ratio of variance 1 to variance, and we're going to see how we calculated the F. Okay, The F is really the ratio of this variance to this variance. That's why we wanted to have the bigger variance on the left side. So if we're going to go ahead and divide the 160 divided by this one here, notice here we're going to get the same exact value, this one here to this one here. You might think this has more digit to the right of the decimal points because I don't have enough width in the column to show the same exact number of digit to the right. So what is the conclusion here? The conclusion, the F value is greater than the critical one tail value. Therefore, we reject the null hypothesis as a result. So this is the case. 7.37 is greater than 6.25. I'm actually limiting 2 digits to the right of the decimal points in my discussion. Therefore, clearly, we reject the null hypothesis. The variance of the two populations are unequal. They are not equal. 120 versus the 21. So that is clearly the case. Again, thank you very much for watching this video, and we're going to continue in the next video to discuss t-test, and I hope to see you there. This is Dr. Sam Hijazi. Happy that you watched this video. Bye-bye.